Okay, so the definition of acceleration is change in velocity over change in time. Now, velocity, what's special about velocity rather than speed? It has direction, okay? So, looking at our Ladybug, not this one. All right, so now the stink bug is riding along too, and they're going around and around. You can see the velocity arrow there. If I add in the acceleration vector, so look at the acceleration vector. Where is it pointing? To the center. What did Bill Nye tell us about things that point towards the center? They have they're centripetal. Okay, the word centripetal means center seeking. So this is the center seeking acceleration. So all the time as this bug is going around, this acceleration is making this velocity change direction. Notice that the velocity of the ladybug is down, right, up, left, down, right, up. Is the velocity of the bug changing all the time? Yes, because the direction is changing. And if the direction is changing, then you have to have an acceleration. Is the ladybug going at a constant speed? Yes. So, the next time you're at trivia and you're asked, when is an object accelerating but the speed is constant, then the answer is when it's moving in a circle. And you'll be like, yay, physics. And it'll be the only physics question you hear at trivia for months and months. Okay? But it's really common because a lot of people are like, oh, that can never happen. But no, we can totally accelerate with our speed being the same because we're changing the direction all the time. Now, let's go back and look at our notes here. So, if acceleration is change in velocity, and let's say initially we have a velocity, well, we have a circle. That's not a circle. That's a perfect circle for me. And let's say that we're going to look at an object that is here, and it's going to rotate till it's over here. Equal height, all that kind of business. All right. Now, at this point right here, it has a tangential velocity or a tangential speed that would be directed tangent to the circle. Here, it's down like that. And if it's not changing its speed, then this v value is the same as this v value. Okay? And if I look at a horizontal line there, this theta would be equal to this theta right there. And I didn't do a good job of drawing it, but hopefully you see enough. And mathematically, if this is the center of the circle, and this is the midway point, this will also be theta, and this will be theta. Now, we've done this whole vector component thing. The velocity in the x direction would be v cos theta, and the velocity in the y direction would be v sine theta, like that. Now, is the x component changing from here to there? X component would be adjacent. It would be cosine. So this would be v cosine theta. What would the x component of this one be? V cosine theta. Did it change? No. Did my y component change? It was positive v sine theta for this piece. What's my y component when it's below the horizontal? Negative v sine theta. So my velocity in the y direction is changing. So because the final velocity is negative, the initial velocity is positive, we get negative 2 v sine theta is the change in velocity in the y